Welcome to spmathsolutions, real numbers, 10th class maths, theorem 1.6. Let p be a prime number if p divides a square where a is positive integer, then p divides a. Solution proof: given that p is a prime number and p divides a square. Now we have to show p divides a. P divides a square, which means a square divided by p. Let the prime factorization of a is a equal to p1 into p2 into p3 into and so on pn, where p1, p2 and so on pn are primes which are not distinct. Not distinct means there is a repetition. Then a square is equal to a into a, p1 into p2 into and so on pn into p1, p2 and so on pn. It is equal to a square is equal to p1 square into p2 square and so on pn square, given that p is a prime number and p divides a square. Now a square is prime factorization of p1 square, p2 square and so on pn square. P is one of the prime factors of a square. See here, a square is equal to square of prime numbers. P is a prime number, one of the prime number in the a square. A square is equal to p1 square, p1 into p1. p1 square is a factor of a square, also p1 is a factor of a square. Now we have to take uniqueness, means distinct prime numbers, not repetition, no squares. Only p1, p2 and so on pn, these are factors of a square. Here we are talking about the factors only, not the values. The prime number p is one of the a square అయినప్పుడు prime number p is one of the p1, p2 and so on pn కూడా అవుతుంది కదా. Therefore p is one of p1, p2 and so on pn. That implies p divides a. Given that p is a prime number, p divides a square, then p divides a, which means p is one of p1, p2 and so on pn. p1, p2 and so on pn is the prime factorization of a. That's why p divides a. Hence proved. Please subscribe our channel.